So in this clip we're going to look at solving equations with algebraic fractions again, at a slightly different scenario. And again, this is a question from a past paper, and the question says, show that 7 plus 10 over y plus 2 is equal to 9 over y simplifies to the quadratic y squared plus 15y minus 18 equals 0. And then a second instruction, solve the quadratic. So it's a two-part question. And the first one is where we deal with the algebraic fractions. So let's take a look at that. Okay. So, as in the last video, where I demonstrated removing the denominators, that's exactly what we would do here. And the first thing to do would be to multiply by y throughout. So that's what I've written here. And doing that gives me this y here as a multiplier, this y here, not the bottom one, the top one, as a multiplier, and it gets rid of this y on the final fraction. So that's the first denominator removed. And then secondly, we would look at this denominator, y plus 2, as a single piece of information, and again multiply by it throughout the equation. And so we end up with what's written here in blue. We have y plus 2 as a multiplier in the first term. In the second term, the y plus 2 disappears, and in the right hand side of the equation, again the y plus 2 appears as a multiplier. What we would then do is to expand the brackets, and so the red arrows indicate which bit multiplies which bit. Should be fairly familiar to you by now. And on this row, what I've done is circled the terms that are alike on the left hand side, and so when we gather those together we end up with 7y squared plus 24y, that's these two put together, is equal to 9y plus 18. Okay, so far so good. It's starting to look a little bit like the target that we have, but we have to do a little bit more to it to make it happen. So the last two things here are to take away 9y from both sides. So we're going to remove it from here and remove it from this 24y to give us 15. And then finally we're going to remove the 18, which leaves us 0 on this side and a minus 18 on the left. And if you look back at the question, you will find that that is your target quadratic. Now, to resolve the quadratic, we have to have a look at the methods for solving quadratics with a leading coefficient, and there is a video on this on the channel, but I will just go through it. So if we have a leading coefficient, the method is to multiply that coefficient by the number at the end, and in this case that gives us what we see written in blue here on the second row. We then have to consider factors of that number on the end, and I've written those down here, and we need the pair of those that's going to allow us to create 15 in some way, and 21 take 6 is indeed 15. So, sorry, it's a bit wobbly. That is definitely the pair we're going to use, and we transfer the 21 and the negative 6 to the brackets that we have waiting for our solution. We bring down the 7y but not the squared into each of the brackets, and at this stage we have to remember that we introduced a factor of 7 right at the beginning of the solution, so we have to get rid of that. And if you look at the two brackets, this one would not divide by 7, but this one certainly will. And if we divide that by 7, we get y plus 3. The other bracket remains the same, and it's then just down to the solution of that, which is where we consider both of those brackets being equal to 0. If the first one was 0, then we would end up with y is minus 3, and if the second bracket was 0, then we would end up with y equals 6/7. Now, if I've gone through that last part of the question a little too quickly for you, please do refer back to the video on solving quadratics with a leading coefficient.